So let's take a look at this number 22, which is very similar to 21. We're just starting off with this point slope formula. So we spent a lot of time rewriting this on the last paper there, so we can commit it to memory and make sure we understand how to do everything. Okay? And one of the big takeaways when we were doing this was that we kept getting a lot of double negatives. Okay? So there's a negative in the formula. There's two minus signs, subtraction signs, in the formula. So when we're looking at this formula, we want to be able to tell, well, what point is this talking about? Right? So we want to look at this and say, well, this is the point, the x, positive 2. Because it's subtracting a positive 2. So the point itself is positive 2 for x. And same thing here, it's subtracting positive 3. Okay? So it looks like this would be like a negative sign, and maybe you're thinking this is negative 2. This is just the subtraction sign from the formula. It's these. It's not counting as a negative sign of the number. So got to be very careful so we don't end up graphing everything wrong. If we looked at this and said, oh, this is negative 2 and this is negative 3, as soon as we start graphing, everything's going to be wrong, every single problem. So small but very important detail. And then we have a positive 2 here for the slope, which of course is the same as 2 over 1. So the 2 is the rise, the 1 is the run. Okay? And that's basically it. I'll start, Alan. Everybody knows. Okay, so we go up 2 over 1. And of course, positive 2 over positive 1 is the same as negative 2 over negative 1, because that does equal positive 2 as well, right? So we can also go down and left. So down 2, left 1, down 2, left 1. Right. And of course, always use a straight edge. Never draw a line freehand. So your student ID card is a really good straight edge. Okay. Go ahead and draw that. If any of your points are not on your line, that means you might have counted your squares wrong. So don't just draw your line through them no matter what. It has to be exact. Okay. All right. So that's basically it. Identify the correct x1 and y1. Identify the slope, and then if it doesn't have a run, we know to put it over 1. Go ahead and graph everything. Not too bad. So let's practice on number 2. What is the x and what is the y? Yeah, what is the x here? Now recall that here is a minus 2. The correct point was positive 2. So if you see a positive 4, what do you think it should be?
Negative 4.
Negative 4. All right. And same thing with y. You see a positive 1 or a plus 1. That's going to be a minus. Okay. Here's why. This is already simplified, but the formula is minus a negative 1. So this is what we did yesterday. We saw a bunch of double negatives like this. So that's why it's coming out to be negative 1 for y, because it's minus a negative 1 and minus a negative 4. Okay? So we're not just going to memorize some rules like, okay, make sure you switch the sign and not have any good reason for that. Okay, it's just that we simplify double negatives. Okay, the slope is negative 1 over 2, which is down 1, right 2, which is also the same as 1 over negative 2, which is up 1, left 2. So you can use both slopes, so you go both directions. We got what? Negative 4, negative 1. Down 1, right 2. Down 1 over 2. Down 1 over 2. Okay. Then also up 1, left 2. There we go. Straight edge. All right, so not too bad. But what happens when we start missing numbers? Okay, so if you look real fast, like at number 4, you can see that we're missing a number, right? We know that this is going to be positive 7, but what about the y if it's not written there? Yeah, so that would be the same as, so if I had this, I wrote it out all the way, what number could I put in that empty place so that it would not change its value? Yeah, so if I put in a -0, that's the same exact thing as just y. Y minus 0 is the same as y. So that's how we know the missing value is 0. And that's what most of these are going to be about after the first few, is just, do you know what to put when there's something missing? So we can go down and look at a few more. So same thing on number 5. We see that the y is missing the number, so we know that it's going to be 0, right? Flip it over real fast. Let's look at those. What about number 7? What's missing there? The m. So what number can we put here that would not change its value? All right, so we can do this. Yeah. Now, if I put a 0 here, what would happen? 0 times x minus 4 would be 0. So it would not make this thing the same. You want to keep it exactly the same. So if you put a 1 here, 1 times x minus 4 is still x minus 4, so it doesn't change it. So that's how we're deciding whether to use zeros or ones. In general, if you're adding or subtracting, and it's missing a number, use 0. So if it's missing if either point is missing for x and y, use 0. If the slope is missing, you're going to use a 1. Okay. So this would be, the rate of change would be 1, which is the same as 1 over 1. That's up 1, right 1. Right. And what about number 9? We're missing the y, and we're missing the x, right? So both of them are 0. And then what's the slope? What's the same as negative? Yeah, negative is the same as -1. So we could rewrite this as y minus 0. Y minus 0 is the same as y. And on this side, we could write, instead of just negative, we can write -1. And x is the same as x minus 0. That's really what we're just doing this for, is to make sure we understand if something's missing, what are those missing values. As long as you don't change anything and they're staying equal, you're good to go. All right. So go ahead and work on those, and then at the bottom, there are a few solving equations and simplifying. Just remember the rules and show all the work and all that good stuff. So you can add 2 to both sides. Make sure you draw the line. Make sure it's neat. Line everything up. If you do want to use the tiles, you can, but at this point we don't need to. You don't want to. So you can divide both sides by 2 over 5 or multiply by 5 over 2. And remember, it is mathematically and socially unacceptable to say that you can't do this because there's a fraction. Because number 1, we have calculators. Number 2, that was 4 or 5 years ago. We can't say math from 4 or 5 years ago is too hard. If you say fractions are too hard, here's what you're saying. 8 times 5 is 40, divided by 2 is 20. I can't do that. Right? That's what you're saying out loud to the world when you say, well, I can't do fractions. 8 times 5 you can't do, and then 40 divided by 2 you can't do, which is completely false. So don't say something like that when it's not true. Okay? Perfectly fine. It might have been difficult a little while ago, but don't keep telling yourself that. It's just basic multiplication and division, nothing more. Okay? All right, so go ahead and get to work. Once you're finished, you can check Aries and anything that's not up to date, or if you have late assignments, you can bring those up to me. Have your, like the stained glass, I think I'll be collecting a little later today as well. Okay? Okay, just